Linear regression is one of those key fundamental ideas behind machine learning, but since it sounds complicated, a lot of people quit and assume machine learning is too hard for them. So, we'll go over linear regression today in a way that'll take you all the way back to middle school math. In other words, this video could be understood by a 6th grader. First things first, understand that the general purpose of an AI model is to make predictions, whether that's classifying items, providing recommendations, or predicting future values. That means anytime we mention we're training a model, what we really mean is improving a model's ability to make predictions based on more data. So, linear regression is an example of a technique we use to make predictions with a model. We use it to find the linear relationship between features and a label. So what in the world does that mean? A feature is just a fancy way of saying input or variable, or something you plug in to see what happens. For example, if someone was trying to find the relationship between hours studied and grades received, the number of hours studied would be a feature in the model. The label, on the other hand, is what you're trying to find out. So in our example, we're trying to see if there's a connection between how many hours you study, the feature, and the score you get on the test, the label. Where linear regression comes in is to help us figure out how these two things, features and labels, are related. Specifically, it's asking, if I increase the number of hours studied, how does that change the test score? Or, is there a way to draw a straight line that best shows this relationship? This line is our best fit, and it gives us an equation we can go to use to make rough estimates on what the label should be, depending on the features. This should all seem very familiar from middle school math, but that's not it. The equation we use for linear regression is in a form you probably know, the classic y equals mx plus b. However, instead of y equals mx plus b, we tend to use different notation for linear regression. Y prime is equal to w1 x1 plus b, where y prime is our predicted label, our output, b is our bias, w1 is our weight, and finally, x1 is our feature, the input. Don't worry too much about the vocabulary here. All you need to know is that changing these values changes the line of best fit. During the training stage, the model calculates the best weight and bias to produce the best predictions. So, in essence, linear regression creates a linear equation that models the relationship between the input features and the output labels. This will all make perfect sense with an example. Imagine you'd like to predict the price of a house given a couple of its features: square footage, number of bedrooms, age, etc. The first thing you could do is go online and search for houses with very similar attributes. Now that you've got a good data set, we'll try graphing the relationship between each feature and the house price to see if there's a pattern. For example, we could plot square footage on the x-axis and house price on the y-axis, and each point on the graph would represent one house from our data set, showing its square footage and price. If the points roughly form a straight line pattern, great news! There's a linear relationship between square footage and price. This line is what linear regression will give us, and once we have it, we can use it to make better predictions. By plugging in new square footage values into this equation, we can predict the price of a house, even if we've never seen a house with exactly those features before. The line acts as our model, and the more accurately it fits the data, the better predictions it will make for new inputs. Now, note that when we add more features, like number of bedrooms, age, or lot size, our equation begins to grow. Instead of just y equals wx plus b, it turns into something like y equals w1 x1 plus w2 x2 plus w3 x3 plus b. Here, each feature, x1, x2, x3, etc., has its own weight, w1, w2, w3, etc., representing how much that feature impacts the price. The model will adjust the weight to best match the data, helping it make more accurate predictions across multiple features. And that's it. That's all you need to know about linear regression. Let's quickly review what we went over today. We learned that 1. Linear regression finds relationships between features and a label to make predictions, like house prices based on attributes. And 2. We covered the basic equation, y equals wx plus b, and how it expands with more features. Now you know how linear regression works, and next time, we'll talk about loss functions. That's it for now. Hope that helps.